All right, why don't we begin? Welcome to today's webinar, a deep dive into what separates the apps we delete from the ones we can't live without. Whether you're building your first MVP or navigating the chaos of hypergrowth, you already know one thing. It's not enough just to build an app anymore. You have to build an app that performs under pressure, earns user trust, delivers delight, and, let's be honest, feels a little bit like magic. In the next hour or so, I'm going to walk you through a story that every successful mobile product must live through. It's the journey from, hey, I think we've got something here, to millions of people are relying on this thing every day, don't let it crash. I'll begin with scalability, because even the most brilliant app idea will buckle under real-world load if the architecture behind it can't stretch. I will explore both the app layer and the back end, digging into what it really takes to design systems that perform flawlessly, whether you're supporting 1,000 users or 10 million. Think of this part as your app's gym membership. No gains without strength. Then I will zoom into security, the silent guardian of user trust. I will expose some of the key risks lurking in mobile development and share proactive, modern strategies to safeguard user data, because you can't scale if you can't be trusted. And let's face it, nobody wants to be that headline. Next, I will shift gears into growth, not the vanity metric kind, but real sustainable user acquisition and retention. I will unpack how to build growth engines that scale, not just in downloads, but in meaningful engagement, referrals, and yes, revenue. Finally, I will land on a topic every great app eventually tackles: habit formation, or as I'm calling it, making your app addictive, obviously in the best possible way. I'll explore what makes users come back, what keeps them engaged, and how you can ethically craft experiences that feel indispensable and not manipulative. So whether you're here to fine-tune a product already in market or build something brand new that people can't stop using, you're in the right place. This is going to be a no fluff, high signal, all substance ride through the technical, behavioral, and emotional layers of mobile product mastery. So let's get started. It always starts the same way. You've just shipped your app, it's fast, clean, and your friends tell you that it feels snappy. A few hundred users trickle in, then a few thousand. Your dashboard lights up like a Christmas tree. Growth is happening. You're excited, a little terrified, but mostly excited. Believe me, I've been there a few times. But then the cracks begin to show. The API slows down. Your mobile app takes forever to load content. A new feature quietly breaks something 2 layers deep. Users start complaining. Your servers begin to sweat. You check your logs, and it's just stack traces everywhere. Congratulations. You've just met the real villain of modern software: unscalable architecture. Today I'm going to talk about how to avoid that moment, not with duct tape and luck, but with real architectural discipline. This is a deep dive into scalability, what it is, how it works, and why mobile apps, yes, even the pretty ones, fall apart if it's not built in from day one. Let's set the record straight. Scalability is not some abstract technical fluff cooked up in the corner office. It's not just about handling more users. That's like saying relationships are just about spending time together. Technically true, but wildly incomplete. In engineering, scalability is a system's ability to grow without blowing up in complexity, cost, or chaos. It's how we design software that doesn't just work on day one, it thrives on day 10,000, with 1 million users across regions, across devices, and across time zones. It's about building systems that don't panic when traffic spikes, services fail, or your CEO decides to announce a surprise feature in their keynote. It's about stability under pressure, performance at scale, evolution without rewrites. And in the world of mobile-first software, where the app is both the storefront and the product, scalability is existential. Let's take a breath and get technical for a second. From a systems architecture perspective, scalability means one thing: the ability to handle increased workload without sacrificing performance or stability. There are two ways we scale: vertically and horizontally. Vertically, which is scaling up, adds more power to a machine: CPU, memory, or disk. It's simple, like putting a turbo engine in your car. But it's also finite and expensive. You hit physical and economic ceilings very quickly. Horizontal scaling is when you scale out, which means you add more machines or services. You distribute the load. This is the world of microservices, containers, distributed databases, and cloud-native everything. It's infinitely more flexible and infinitely more complex. The right architecture isn't just about throwing more compute at the problem. It's about knowing how and when to scale, and building systems that are ready to evolve without collapsing under their own weight. If you remember nothing else from this session, remember this: scalability lives at the intersection of three pillars: performance, reliability, and maintainability. Let's talk about performance, which is the most visible part. When users complain your app is slow, they're talking about performance. But performance isn't just front-end animations or back-end response time. It's the entire experience. It's whether the screen renders smoothly even with 10,000 records, whether tapping a button kicks off an API call that returns in 200 milliseconds, not 2 seconds. It's about how you handle concurrent requests, optimize queries, use CDNs, preload assets, and minimize network chatter. Performance is what earns user trust. You cannot fake it. Next up is reliability. Scalability without reliability is like building a suspension bridge out of toothpicks. What happens when the database starts choking? When an external API goes down? When 5 services are calling each other in a circle and one times out? Scalable systems are resilient by design. They don't assume the happy path. They implement retries, fallbacks, and circuit breakers. They log intelligently and recover quickly. They fail gracefully and visibly, not silently and mysteriously. And finally, we have maintainability, something no one likes to talk about. Because sure, your system scales to millions of users, but can your engineers still deploy confidently? Can they onboard without reading 50 pages of tribal knowledge? Can they change a feature flag without setting off a domino chain of outages? Maintainability is what lets you move fast and not break things. It's clean API, modular code base, proper CI/CD, and dev environments that mirror production. It's feature flags, rollback tools, and test coverage that doesn't cry in the corner during a release. Scalability isn't just, can we handle more traffic? It is, can we do it repeatedly, safely, and without waking the on-call engineer at 3 a.m.? If you want a gold standard, look no further than WhatsApp. It started small, just a simple chat app, a few thousand users, minimal backend. Fast forward a decade, and now it supports over 2 billion users, sending messages, photos, and videos in real time across the globe, 24/7. Here's what made WhatsApp scalable. They wrote their backend in Erlang, a language built for distributed, fault-tolerant systems. They kept their infrastructure lean and efficient. They used custom protocols instead of bloated REST APIs. They used intelligent caching and asynchronous messaging everywhere. They also embraced horizontal scale very early, sharding messages, decoupling services, and planning for failure like it was inevitable. Because let's be honest, it is. And most importantly, they scaled without compromising reliability or maintainability. WhatsApp didn't just scale their servers, they scaled their architecture, their operations, and their culture to support a system that never sleeps. You don't have to be WhatsApp, but you do have to be ready. If your product is growing, if your user base is climbing, your feature set is expanding, if your team is hiring, then scalability is already knocking on your door. It's not a someday problem, it's a today problem. But it's disguised in your GitHub issues, slow endpoints, and hey, it works on my machine set of problems. Because growth is only a good thing if your system can keep up with it. In the next few slides, I'll be unpacking scalability across two critical fronts. Front-end scalability, which is the mobile app layer, and back-end scalability, which is the infrastructure layer. On the mobile app layer, we're going to be talking about topics like how do you build mobile clients that stay fast, snappy, and resilient. Even as the app grows in complexity, the network gets flaky, and your user base stretches across continents and devices. On the infrastructure side, we're going to talk about what it takes to build back-end systems that scale horizontally, fail gracefully, and still ship features weekly without causing regression or some gray hair. Or in my case, no hair. Because when your app starts to take off, both layers need to hold the line. You can't scale one without the other. It's a team sport, a balancing act, a war against entropy. And the best time to start building for scale? Before you need it. Let's shift gears and dive into the front-end layer of scalability architecture, the part users touch, tap, and rage quit when it lags. In mobile apps, the front end is the battlefield where every millisecond matters. You can have the most elegant backend in the world, sharded and containerized to perfection. But if your mobile UI stutters, freezes, or takes 5 seconds to load a list of items, users don't care what's under the hood. They'll uninstall your app and move on. Harsh? Yep. And true? Absolutely. So when I'm talking about front-end scalability, I'm talking about your app's ability to maintain responsiveness, reliability, and usability as it grows in features, data, complexity, and users. Let's unpack what that means in real terms. Every app starts with a simple UI, a few screens, some buttons, maybe a list or two. But give it time, and suddenly you're dealing with infinite scrolls, complex animations, real-time updates, nested navigation stacks, and screens that are basically tiny operating systems. And as the UI grows, performance starts to erode. Not because of one big problem, but because of 1,000 little problems. So how do you stay fast when things get big? A few things. One, use lazy loading. Don't load 100 items at once when the user only sees 10. Use list virtualization. Number two, memorization and pure rendering. Only re-render what actually changed. Your CPU will thank you. Number three, offload heavy work. Anything that blocks the main UI thread, like image processing, JSON parsing, should be done asynchronously. And last but not least is the skeleton loaders and placeholders. Trick users into thinking your app is faster than it is. It's not lying, it's the UX. So if your UI stutters every time someone scrolls, that's not just a bug, it's a scalability warning shot. As your app scales, so does the chatter between your front end and back end. Thousands of users tapping buttons leads to millions of network requests. If you don't handle that traffic smartly, your backend is going to need therapy, and your users will be staring at infinite spinners. So, what are the strategies to tame that traffic? 4 things to keep in mind. Number 1, batch your API requests. What does that mean? Minimize your round trips. If you're making 3 requests that can be 1, you're wasting cycles and your radio. Number 2, caching. Cache aggressively, but do it responsibly. Use stale while revalidate patterns to keep content fresh and fast. Number 3, pagination and infinite scrolling. Send only what's needed and when it's needed. Loading the entire data set just in case is the sure path to ruin. And number 4, provide retry logic with exponential backoff, which means don't hammer your servers with blind retries. Handle errors like a grown-up. One of the most underappreciated aspects of front-end scalability is offline resilience, especially in emerging markets or flaky environments like elevators, tunnels, airplanes. Your app should degrade gracefully. There are 3 features that say, hey, we thought about this. Number 1, local caching with intelligent synchronization. Strategically queue up writes while offline, and then synchronize them all when back online. Number 2, have a graceful fallback mode. For example, say, sorry, you're offline. That's better than crashing. A read-only state is even better. And number 3, delta synchronization. Don't read-download everything. Synchronize only once changed. Bonus points if you can compress it. So front-end scalability isn't just about volume. It's about variability. Your app should perform well in both Silicon Valley and rural Tanzania. As the app grows, so does the team. And suddenly 5 developers are trying to ship features into the same code base. Without structure, things get messy, and they get messy very quickly. So I have 3 examples where modular code equates to scalable team. Number 1, feature modules. Break the app into logical units: authentication, feed, chat, settings, each with its own boundaries. Number 2, shared utilities and design systems. Please avoid reinventing the button 5 times. And number 3, cross-platform strategies. If you're building for iOS and Android, use tools like Kotlin multi-platform, Flutter, or React Native wisely. Write once and optimize everywhere. And if you think this doesn't matter, wait until your build time hits 40 minutes and you can't merge PRs without triggering a full team meeting. As your front end grows, debugging blind is no longer an option. You need visibility into performance, errors, usage, and user pain. There are 3 tools that should be in every scalable app. Number 1, crash reporting. Use tools like Firebase Crashlytics, Sentry, or Bugsnag to catch and categorize crashes when it's in the wild. Number 2, performance monitoring. Measure startup time, time to first render, frame rate drops, and slow taps. And number 3, real user monitoring. Know what users actually experience on different devices, different networks, and operating system versions. Front-end observability turns it's slow for some users into actionable, reproducible, and fixable issues. Scalable front-end design is about more than UX polish. It's about system integrity under pressure. It's about staying smooth when everyone's scrolling. It's about synchronizing across flaky networks without corrupting the data. It's about building a code base that 5 teams can work on without tripping over each other. And it's about knowing when things break before your users tell you. Front-end scalability is where perception meets engineering reality. Users don't care if the backend is bulletproof if the thumb freezes on a blank screen. Up next, I'm heading into the back end, where concurrency, consistency, and chaos reign supreme. Because for every tap on the front end, there's a back end call working overtime to make it seem like magic. Now let's step behind the scenes, beyond the mobile UI, past the loading spinners, and into the heart of the machine, the back end. This is where the real action happens. It's the engine room of your app, the unsung hero of every smooth user experience, and it's where scalability gets really serious. Here's the thing. Mobile front-end performance might be the face of your app, but the back end, that's the circulatory system, the nervous system, and digestive tract all rolled up into one. And if it breaks, the whole body seizes up, no matter how pretty the UI is. As your app grows, more users, more features, more data, the back end is the place where that growth gets felt first and hardest. And if your architecture isn't built to scale, it'll let you know painfully and usually in production. So let's break down what it really means to build a scalable backend, one that doesn't just survive scale, but gets better because of it. Let's start with the question that has broken engineering Slack channels everywhere. Should you build a monolith or go microservices? Well, the truth is it depends. Monoliths are great when you're small. Everything's in one place, simple to deploy, easy to debug. For early stage startups, a well-structured monolith can scale surprisingly far. Microservices, on the other hand, are about decoupling. You split your app into independently deployable services, such as authentication, payments, notifications, etc. And each of them is responsible for a specific domain. This allows you to scale each service independently, ship features faster with isolated deployments, and isolate failures, like a broken search service shouldn't break the login. But, and this is a huge but, microservices come at a cost. You have service discovery, orchestration, distributed tracing, network latency, and the ever-looming threat of circular dependencies. If you're not ready for that complexity, they'll bite, and they'll bite pretty hard. So my rule of thumb is start monolithic and go micro intentionally when growth demands it, not just because it's trendy. If your backend is the house, your APIs are the front door. And if a million users show up at once, that door better not be a revolving one that jams. So there are 4 ways that you can scale the APIs. 1, keeping the endpoints lightweight. Avoid chatty APIs. Each endpoint should do one thing and do it fast. Use pagination and filtering. Never send a million records just in case. The next design pattern is rate limit and throttle. Protect your services from overzealous clients, distributed denial of service attempts, and accidental infinite loops. And last but not least is an API gateway. So centralize your routing, your caching, your authentication, and observability. One entry point to rule them all. Some examples of API gateways is Kong, Apigee, or AWS API Gateway. And don't forget versioning, because one day you'll change something and an older app version will panic, and so will your users. So let's talk about database scaling. Databases are where dreams go to die when not scaled properly. At low scale, everything's great. Everything is peachy. A few queries, a few joins, maybe some JSON columns. But as you grow, your reads pile up, your writes become bottlenecks, your queries slow down, locks happen, and then your database basically says, I'm out. So what can you do about these things? Well, you can use read replicas, split reads and writes. Use replicas for heavy querying, dashboard, and search features. You can also use sharding, which is break the data into logical partitions. For example, user ID ranges. Each shard gets its own instance, but be careful. This introduces complexity fast, so shard with caution. The third thing you can do is cache. Use Redis or Memcache to reduce your database hits for frequently accessed data. Hot data lives in memory, not on disk. And last but not least is consistency. Sometimes it's okay if data takes a few seconds to synchronize, as long as it's eventually correct. Don't force strong consistency on every interaction unless you really, really need it. If your backend tries to do everything synchronously, you're begging for bottlenecks. Not every task needs to happen right away. Some can be deferred, some can be queued, and some can be retried. So where do queues shine? Sending emails, processing images, push notifications, analytics, and synchronizing with some third-party or external services. You can use tools like Kafka, RabbitMQ, Amazon SQS, Google PubSub. These let you build systems that are decoupled, fault tolerant, and elastic. If you want to survive Black Friday traffic, start loving your message queues. At scale, debugging production issues from logs is like trying to solve a crime with only a blurry photo. You need real observability. You need to have metrics with requests per second, error rates, latency spikes, things like that. You also need to have logs, structured, centralized, and searchable logs. And please have them with some kind of a context. You need to have tracing, distributed tracing across various services to understand where the time is spent. And last but not least, have some dashboards and some alerts. So there's some tools out there like Grafana, Datadog, Prometheus. Whatever your flavor, make it actionable. Traffic patterns are quite weird. One minute you're calm, the next someone posts your app on Hacker News and your CPU hits 99% like it's a badge of honor. That's where auto-scaling comes in. Cloud-native platforms like Kubernetes, AWS ECS Fargate, or Google Cloud Run let you scale your workloads based on metrics like CPU, memory, and request volume. Please use health checks, readiness probes, and load balancers to keep traffic flowing smoothly. And implement circuit breakers and fallbacks. You can use tools like Hysterics or Poly to prevent cascading failures. Don't build brittle systems. Build adaptive, self-healing infrastructure that can flex with the load. So, backend scalability isn't just about raw power. It's about architectural clarity, fault tolerance, and observability under fire. The best systems are built with growth in mind, instrumented to expose pain before it hits the user, modular enough to evolve, and resilient enough to recover. But here's the truth. At some point, your app is going to succeed, or go viral, or get denial of service attacked. And when it does, your backend will either rise to the occasion or become a very expensive and very public failure. The choice is yours. Next up, I'm going to tackle real-world failure modes, load testing strategies, and how to design for graceful degradation so your app doesn't just scale, it scales smart. Let's get one thing clear. Even good architectures break under scale. Yeah, the ones with diagrams, the ones that pass QA. Scale is the great equalizer. It finds the weak links, the assumptions, the shortcuts you swore you'd refactor later, and it doesn't just knock gently, it kicks the door in. So if you want to build systems that thrive under pressure, you first need to understand what fails and why. Let's walk through the top 5 scalability failure patterns, brought to you by real-world meltdowns, postmortems, and engineers who now flinch when they hear the word monolith. And trust me, I speak all this from my own personal experience. First is the monolithic bottlenecks. So the monolith, what is it? It's simple, cozy, and easy to get started, and a nightmare to scale. Large, tightly coupled code bases work great until they don't. When your login page reporting engine, and PDF generator are all deployed as one binary. Scaling one means scaling them all. Want to double the capacity for just your media processing service? Sorry, you're redeploying the whole house to change a light bulb. Monoliths can also slow down deployments, cause cascading failures, and create team turf wars over code ownership. Monoliths are fine until growth demands flexibility. Then they become architectural quicksand. The second scalability pattern is synchronous dependency chain. So in theory, services calling other services in a neat little chain sounds great. In practice, it's a Rube Goldberg machine of latency and fragility. If service A waits on service B, and service B is having a bad day because it's waiting on service C, well, congratulations. You've just built a domino rally of doom. This is known as the Death Star architecture, a web of tight, synchronous dependencies that take the whole system down, even if one node sneezes. If your service can't answer a request until 6 others do, it's not a service. It's a hostage negotiator. The third pattern is inefficient data models. Your database is the backbone of your system, and like any spine, it's very sensitive. Bad data modeling is a silent killer. You won't feel it until your queries start timing out, your indexes balloon, or your read replicas throw up their hands. There are 4 common culprits. The first one is the N+1 queries, a lazy developer's rite of passage. 1 call per row. You're going to have a bad time. The second culprit is under-normalization, which leads to duplication and inconsistent updates. Number 3 is over-normalization, which leads to spaghetti joins that choke under your load. And the fourth culprit is no sharding strategy. Everything is great until one table grows like it's on performance-enhancing drugs. A schema that works for 1,000 users might break completely at 100,000. Think long-term. Index smart. And query even smarter. The fourth pattern is the lack of back pressure and throttling. This one's a classic. Your system is fine until it gets popular. Then it gets overwhelmed, queues explode, threads block, and suddenly, boom, everything is on fire. Without back pressure, a system can't say slow down. Without throttling, it can't say no. The result? A denial of service attack from your own users. Like any relationship, your services need boundaries. If they take on too much, they burn out. The fourth pattern is poor observability and alerting. You know what's worse than a failure? A failure you can't see. Too many systems scale blind. No dashboards, no distributed tracing, no real-time logs. So when something breaks, the team is left piecing together a story from log lines like detectives in a murder mystery. Metrics should be real-time. Alerts should be actionable. Dashboards should be glanceable. And tracing should follow a request across services like a detective following footprints through the crime scene. If you can't answer what broke and why in under 5 minutes, your observability isn't ready to scale. Scalable systems aren't proven in architecture diagrams. They're proven under pressure. Let's talk about how to simulate that pressure before it happens for real. Load testing is where you trade idealism for realism. You simulate chaos on purpose so your systems can fail in private, not in production. There are 4 best practices for load testing. Number 1, simulate realistic traffic. Tools like Locust, K6, or Gatling can simulate thousands of users clicking, scrolling, and rage refreshing. The next best practice is targeted scenario testing. Don't just hammer the homepage. Test key flows, login, purchase, checkout, uploads, etc. The third best practice is monitor the SLA violations. Measure error rates. measure latency, and measure failure thresholds under pressure. And the fourth best practice is test with production-like data. Synthetic data is just fine, but production-shaped data reveals true pain points, like the 3 megabyte JSON blob your front end loves to send. Load testing is like training in the gym. No one enjoys it, but you'll be grateful for it when the real fight comes. Scaling blindly is like flying without radar. Capacity planning gives you a map. Here are 4 things to watch out for. Number 1, historical usage trends. Know your peaks, your valleys, and how fast your user base grows. Number 2, resource baselines. Track your CPU, memory, network, and disk I/O. Know what normal looks like before things go sideways. Number 3, auto-scaling policies. Define triggers for when to add or remove instances. Don't rely on humans to react at 3 a.m. And the last thing to watch out for is the cost modeling. You need to know what scaling costs you: compute, bandwidth, storage, especially under your cloud provider's surprise billing model. Predictability is not sexy, but it's what keeps systems stable and budgets intact. Inspired by Netflix's legendary Simian Army, chaos engineering is about intentionally breaking things to see what happens and learning from it. Here are some chaos ideas. Kill a node mid-request. Did the system recover? Add latency to an external API. Does your service back off or does it freak out? Partition your database. Does the data remain consistent or does it go weird? If what I just mentioned feels extreme, it is, but it's also the best way to uncover unknown dependencies, assumptions, and brittleness before your users find it. Chaos is inevitable. Better to unleash it on your terms. Scalability is not a checkbox. It's a mindset. It's a long game that asks you to design for tomorrow's problems today without compromising today's velocity. And it's never done. Systems grow, requirements shift, teams change. What scaled last year might bottleneck this year. That's why scalable engineering is equal parts foresight, feedback, and flexibility. You got to ask yourself, will this architecture support 10x more users without a rewrite? Can the API handle 1,000 concurrent requests without locking up? Can we deploy hot fixes in minutes, not hours? If something breaks, will we know immediately or after users leave? In future webinars, I'll dive into advanced strategies like scaling analytics pipelines without drowning in data, edge computing for mobile performance at the last mile, and multi-region deployments to go global without introducing latency hell. In today's hyper-connected world, where your fridge might have Wi-Fi and your smartwatch knows your heart rate better than your therapist, securing your mobile app's backend isn't just a good idea. It's absolutely non-negotiable. Think of your backend like a nightclub for data. You want the right people to get in, like users with valid credentials. Keep the creeps out, like hackers and bots. And make sure that once people are inside, they don't break stuff or wander into the VIP section uninvited. So how do you secure this high-stakes digital venue? You do it with layers, like an onion, or a well-armored medieval knight. Let's peel it back and explore how the professionals do it. The first rule of Backend Club: encrypt everything. Your data is constantly moving, being stored, sent, and retrieved. If you don't protect it, someone will snoop on it faster than you can say zero-date exploit. There are 2 ways to do this. The first way is using transport layer security, or TLS for short. This is what keeps data safe while it's in transit, traveling across networks, through Wi-Fi routers, bouncing off towers. If TLS were a person, It'd be the bouncer who checks IDs before letting any packets into your club. And the second one is Advanced Encryption Standard, or AES. This protects data at rest, sitting quietly in your database or storage. AES is basically a data vault. Even if someone breaks in, they'll need a supercomputer in a few million years to decrypt it. Here's an example of a real-world failure. A mobile fitness app once stored user location history unencrypted. A security researcher pulled GPS logs, revealing not just where the users jogged, but where they slept. Yeah, don't be that app. You've encrypted the doors, awesome. But how do you decide who gets the key? This is where OAuth and OpenID come in. Together, they form the identity power duo of modern systems. OAuth handles authorization. It's what lets your app say, hey Google, can I read this user's calendar? And lets Google say, sure, but only if they agree. And there's OpenID, which handles authentication. It confirms the user's identity and offers handy features like single sign-on, which is one login to rule them all. These aren't just best practices, they're survival tactics. Think of OAuth as the valet who hands out badges at a private event. OpenID is the facial recognition camera making sure the person wearing the badge is actually who they say they are. Let's say your system has admins, users, and support agents. Do they all need access to the same data? Of course not. This is where role-based access control, or RBAC, comes into play. So RBAC ensures people only see what they're supposed to see. Admins get the master keys, users get access to their stuff, and support agents, they can peek into your problem, but not your private messages. Pair this with the principle of least privilege, or POLP, and you got yourself a highly disciplined security system where no one gets more power than they need. You know what's great about a log file? It never forgets. So audit logs track who did what and when. When something goes wrong, and eventually something will, you need breadcrumbs to trace it back to the source. Whether you're detecting a breach, providing compliance, or just figuring out who deployed broken code at 2 o'clock in the morning, good logging saves lives. Well, or at least it saves jobs. Now, there are 5 flavors of app-based disasters. Security is just one piece of the risk puzzle. Because let's be honest, building a mobile app is like trying to launch a rocket in a hurricane. The threats are everywhere. I'll break this down into 5 risk categories. The first one is technical risk. If risks were party guests, technical ones would be the ones who crash early, drink all your bandwidth, and leave you with a production outage and no explanation. Here are some common technical landmines to watch out for. Number 1, platform compatibility issues. It works on the latest iPhone, but it crashes on grandma's Android tablet. Number 2, third-party dependencies. Your app relies on a weather API until you suddenly get 404s. Number 3, scalability failures. Your app goes viral, yay, and then it crashes. Number 4, security oversight. No one noticed the debug endpoint in production until someone else did. Let me tell you about a real example. The fitness app synchronized beautifully with one smartwatch brand, but forgot the rest. By the time they expanded compatibility, users had moved on to competitors. So how do you fight back? Well, you can test across multiple devices, multiple operating system versions, and try as many screen sizes as you can get your hands on. Number 2, use stable, well-documented libraries and frameworks. Number 3, bake scalability into your backend. And number 4, regular security audits. Make sure they're automated and do some manual ones as well. The second risk is operational risk. So these are the risks that don't come from bad code, but they come from bad process. There are 3 usual suspects. The first one is team bandwidth. Not enough developers, not enough designers, and your one project manager is also managing snacks. Number two, broken communication. Nobody knew QA was blocked until the release failed. And number three, scope creep. That MVP turned into a CRM, a social network, and a spaceship. Here's an example. A team once started with a minimalist weather app. A month later, stakeholders wanted augmented reality cloud visualization, drone footage, and smart home integration. It launched late, buggy, and no one used it. How do you prevent this? Simple. 4 things to keep in mind. Number 1, nail down the scope early and guard it like it owes you money. Number 2, use Agile to iterate without spiraling down. Number 3, use project tools like Jira and Trello. These are your friends. Well, until they start generating 400 notifications per day. And number 4, keep communication open, structured, and regular. The third risk is financial risk. These risks show up with spreadsheets, not stack traces, but they can take you down just as fast. Here are 3 money pits to concern yourself about. Number 1, underestimated costs. That quick feature took 3 months and it required 2 additional hires. Number 2, hidden expenses. So you have things like licensing fees, API costs, and other things that you didn't even realize. And the third is delayed ROI. Users love your app, but no one's paying yet. As an example, a language learning app didn't budget for native voice recordings. Halfway through the build, we realized they needed professional narrators. It broke the budget. We shipped with fewer features, and users noticed. How do you armor yourself against this? 4 simple things. Number 1, create forecasts with padding for the uh-oh moments. Number 2, prioritize features with real monetization impact. Number 3, leverage open source unless vendor lock-in is part of the business plan. And number 4, track costs like you track bugs. The fourth risk is legal and compliance. Legal risks aren't just theoretical. They can kill your app faster than a bad review. The 3 legal tripwires to deal with is data privacy violations, such as it's not GDPR or CCPA compliant, and that's a fine. It's a big one. The second legal tripwire is IP infringement, such as accidentally using a copyrighted stock image. They'll see you in court for that one. And the last one is App Store violation. Apple doesn't play. Break the rules, and you get your apps delisted. As an example, a dating app got booted from the store for silently collecting location data. Not only did they lose users, but they also got slapped with fines and terrible PR. So what can you do about this? Number 1, consult legal experts, even if it's just a 1-hour review. Number 2, use transparent privacy policies. Actually tell users what you collect. And number 3, stay up to date with App Store guidelines. They change more often than JavaScript frameworks. The fifth risk is market risk. Market risk is that cruel moment when you realize the product works, but no one wants it. Some of the classic market fails: number 1, lack of adoption. You built the app and no one came. The second is when trends change. You launched a Clubhouse, but it's 2025 and everyone's into AI-powered therapy cats now. And the last classic market fail is when competitors move first. So you launched your smart trip planner 2 weeks after Google dropped their AI-powered version. Oops. So how do you avoid these? Well, do your research, then test, and then research again. Also talk to actual users, not just your internal brainstorming sessions. And last but not least is build fast, launch lean, and be ready to pivot. Scalability is great. Performance is fantastic. But without security and risk planning, your app is always one missed update away from a disaster. So secure your stack, model your risks, Simulate the worst and plan for the best. Because at the end of the day, shipping code is easy, but shipping secure, scalable, and sustainable products, that's the real win. Every app starts with an idea, usually scribbled on a napkin or a whiteboard, maybe dreamed up during a sleepless night or mid-coffee rant. That idea turns into code. The code becomes a prototype. The prototype becomes a product. And then eventually, you find yourself standing at the edge of a cliff called scale. Scaling a mobile app isn't just a technical feat. It's a narrative in its own right. A sequence of chapters, each with its own conflicts, characters, and plot twists. Some chapters are exhilarating, some are exhausting, but all of them are necessary. So let's walk through that journey once you launched. The product is live. Maybe your team popped a bottle of champagne. Maybe you just got right back to writing hotfixes. Either way, now comes the hard part, getting people to actually use it. Acquiring users feels, at first, like shouting into the void. You run a few ads, you post on Reddit, maybe your cousin shares it in the family group chat. Slowly the numbers trickle in. But at scale, this isn't sustainable. You realize it's not just about casting the widest net, it's about finding the right people. The ones who don't just install your app, but open it, use it, and tell their friends. So you start refining your advertising. You experiment across channels. One day it's Google search ads that catch people looking for answers. Another day it's Instagram stories that show off your UI in its best light. You tinker with headlines, test call to action buttons, and hold your breath as click-through rates dance just above or just below your comfort zone. Meanwhile, you realize your App Store listing matters more than you thought. You obsess over keywords, like you're optimizing a novel for SEO. You swap screenshots, rewrite your app description, and find yourself strangely passionate about icon design at 2 o'clock in the morning. Localization becomes a rabbit hole of cultural nuance, and you learn that in Japan, your color palette reads very differently. Somewhere along the way, you realize content is your secret weapon. You start publishing blog posts. Maybe you film a few tutorials. A 5-minute explainer video unexpectedly drives thousands of views and installs. You discover that teaching people something useful builds trust, and trust turns into downloads. And then someone says the magic words. Let's try influencer marketing. Suddenly, you're direct messaging micro-influencers who might be able to bring your app to their loyal audience. A few partnerships later, you start to see the spark, a real uptick. You're not just acquiring users anymore, you're acquiring believers. Acquisition, you learn quickly, is just the first victory. The real war is against churn. You watch the analytics and feel a pang of dread. Some users are bouncing after day one. Some never complete onboarding. Some vanish after week one and never come back. So you start digging. You realize the experience needs to feel more personal. Your app needs to understand who each user is, what they want, and when they want it. You add dynamic recommendations, personalized onboarding flows, and just enough AI to make things feel smart, but not too creepy. You study behavioral patterns through analytics tools, tracking what features users actually engage with versus the ones you were sure they'd love. Push notifications become your new obsession. At first, you send them randomly. New feature alert, and the results are mixed. Eventually, you learn to segment. You send messages to users who need nudges, not spam. You time your outreach with care. You realize that a well-timed push about a new feature feels helpful, but 3 poorly timed pushes in a day feel like spam. You learn restraint. Then comes the revelation of gamification. You introduce streaks. Users begin returning just to keep that streak alive. You build a reward system, points, badges, whatever fits your app's vibe, and people start engaging more, competing, even sharing their progress with friends. One small feature change makes your retention graph curve upward, and the team breaks into spontaneous celebration. You ship frequent updates, not just bug fixes, but meaningful improvements. You start responding to app reviews. You listen, you adjust, and slowly, the people who once bounced stay. With retention stabilizing, your next mission becomes clear. Make money, but do it without annoying the people you just worked so hard to retain. At first, you consider ads. They're easy, right? But quickly you realize that banner ads kill your UI vibe. So you explore smarter models, maybe reward-based video ads or interstitials that only show after a key milestone. You test everything, watch the metrics, and eliminate what doesn't work. Then you introduce subscriptions. You debate internally, monthly, weekly, perhaps even yearly. What features are gated? What's included for free? You roll out tiered pricing and A/B test bundles, keeping a close eye on which plans convert and which ones quietly confuse users into leaving. You start seeing results. Revenue begins to grow. You breathe a little easier, but you don't stop. You test geo-specific pricing, realizing that users in Sao Paulo can't pay what users in San Francisco can. You learn to localize your revenue strategy, not just your language files. Once the product feels stable and revenue is growing, your eyes naturally wander outward, beyond borders. You wonder how your app might perform in new countries, new cultures, new contexts. So you begin to localize for real, not just translate, but transform. Adjust visuals, align cultural tone, switch up imagery, rethink pricing. You realize payment methods vary, that even your sign-up flow might not make sense in every region. To accelerate the process, you look for partnerships, regional influencers, local brands, even government programs. You don't just enter new markets, you build relationships in them. With markets expanding and users growing, cracks begin to show, not in your product, but in your infrastructure. Your servers get stressed, support tickets rise, deployments take longer. You know it's time to scale not just the app, but the operation. You migrate more infrastructure to the cloud. Load balancers go in. CDNs are configured to serve users around the globe faster than ever before. You invest in observability, metrics, logs, alerts, so issues are caught before users even notice. And your team grows too. You bring in more engineers, more marketers, more support agents. You document everything, realizing that scale doesn't survive on tribal knowledge. You turn your scrappy startup into a well-oiled growth machine. You reach a point where the app isn't just an app anymore, it's a brand. You care about the voice you use on social media, the consistency of your tone across emails, landing pages, push messages, and support replies. You realize that brand is what people feel when they think of your app, and feelings drive loyalty. You encourage users to leave reviews. You showcase testimonials. You launch referral programs, turning your happiest customers into your loudest marketers. And somewhere in the middle of all this, you step back. You realize you've gone from launching a product to building a movement. Scaling a mobile app isn't linear. It's not a funnel. It's not even a loop. It's a messy, thrilling, unpredictable journey that spans acquisition, retention, monetization, expansion, infrastructure, and branding. It's a chess game and a poker hand, a math problem and a novel. It requires discipline, experimentation, failure, feedback, and relentless user focus. But when it works, when the numbers grow, the system scales, the brand resonates, it feels like magic. And it's a magic you earned. One user, one iteration, and one late night bug fix at a time. In the wild, bustling bazaar of mobile apps, building something that hooks users isn't a nice to have, it's survival. An app might be well coded, beautifully designed, even marketed to the moon and back. But if it doesn't stick, if users don't feel compelled to come back again and again, it will disappear into that digital purgatory of forgotten installs and untouched home screen folders. So what does it really mean to build an addictive app? One that users can't help but return to day after day, often without even knowing why. Let's clarify something right away. When I'm talking about addiction in the app world, I'm not referencing unhealthy compulsion. I'm talking about habit formation, about meeting fundamental human needs so well, so naturally, that using the app becomes part of a person's routine, like making coffee in the morning, or checking the weather before stepping outside, or for many of us, scrolling on Facebook or Instagram when we should be working. Apps that feel essential aren't born out of luck. They're built with intention, a deep understanding of human psychology, and an empathetic UX strategy that taps into motivation, emotion, and behavior, all without crossing into manipulation. Let's talk about Starbucks, not the physical store, the app. On the surface, it helps you order coffee, but beneath that caffeine-scented convenience lies one of the most quietly effective gamification engines ever developed. You collect stars, you track rewards, you feel a quiet sense of accomplishment every time that little meter fills up. What began as a cup of coffee becomes a quest, and it works. Not because you're addicted to coffee, well, okay, maybe you are, but because you're invested in the ritual. The app fuels it. Now let's look at Runkeeper. Running is already a high effort activity. Logging it, that's supposed to be the easy part. And yet, if a runner forgets to record their jog, they feel like it didn't count. No stats, no progress, no proof. Runkeeper has made itself the official ledger of fitness. It transformed jogging into a data-driven game, each run measured, shared, and celebrated. That's the power of habit loops in action. Let's unpack how they work and why they're at the core of every sticky, beloved app you know. The behavioral science behind habit formation can be traced to 4 pillars: trigger, action, reward, and investment. Apps that master this loop become part of our digital reflexes, which causes addiction. Let's dive into each of these pillars. I will provide some examples and a little bit of humor because even the psychology of dopamine deserves a laugh sometimes. So, the first pillar is the trigger, or the spark that starts it all. Triggers are the catalysts. They are what prompts a user to open the app in the first place. They can be external, like a push notification, or internal, like a feeling. A classic external trigger is the ping you get from Duolingo. It's time for your Spanish lesson, says the owl, gently reminding you that your streak is about to die and your linguistic dreams are slipping away. But internal triggers are even more powerful. Ever felt bored, lonely, anxious? Apps like Instagram or TikTok are right there, waiting to fill that emotional gap with a scroll. You're not just checking for updates, you're feeding an emotional need. And apps that recognize and serve that need become the default destination. But be careful, because spammy triggers kill trust. No one wants a dating app that acts like an ex who won't stop texting you at 2 o'clock in the morning. Triggers must feel thoughtful, not clingy. The second trigger is action, or more commonly known as the effortless gesture. The user does something, checks a feed, logs a run, taps a button. The easier it is to do, the more likely they'll do it. The Starbucks app is a masterclass at frictionless action. Ordering a drink, customizing it, paying, and even tipping, all done in a few taps. In fact, it's often easier than ordering from a barista. Its UX is so seamless, it's addictive. And then there's Instagram, where the primary action, scrolling, is so fluid it feels like gliding. It requires no learning curve, no onboarding. You just open the app and boom, your thumb knows what to do. The action phrase is where many apps lose users. If it takes 5 screens to sign up, or the primary button is buried under a settings tab, you've lost the plot. Habit-forming apps make the action feel almost subconscious. The third trigger is reward, or the hit of delight. This is where dopamine enters the conversation. A reward reinforces the behavior and gives the brain a reason to repeat it. Some rewards are intangible, points, coupons, or stars. Others are emotional, a sense of progress, validation, or even mild amusement. Look at Duolingo again. It dishes out rewards like candy, XP points, leaderboard positions, and congratulatory animations. And when you mess up, that owl is there with just enough guilt to get you back on track. Or take Reddit. You open it hoping to see something funny, fascinating, or infuriating. And most of the time, you do. That unpredictability, also known as the slot machine effect, is a potent form of variable reward. You never know what you're going to get, which is exactly why you keep checking. The fourth and last pillar is investment, which is also known as the reason to come back. This final pillar is where the user gives something back: time, effort, and data. This deepens the sense of ownership and raises the cost of walking away. Think of LinkedIn. People spend hours, days, weeks crafting profiles, listing achievements, and connecting with colleagues. Why? Because once you're invested that much, you don't want to abandon it. Your profile becomes your professional identity. The same goes for any app that lets you build something: a fitness streak, a playlist, a digital garden. The more you personalize and contribute, the more the app becomes yours. And the most effective investment isn't just about data, it's emotional. It's the tiny voice in your head that says, I've come this far, I might as well keep going. Addiction without personalization is a one-size-fits-none experience. What truly seals the deal is when the app feels like it gets you. Spotify nails this with Discover Weekly. It analyzes your taste so well that it often feels like it knows you better than your best friend. Netflix does the same with its uncanny recommendations. You didn't know you needed a 4-part docuseries on ancient curse-breaking rituals, but there you are, 3 episodes deep on a Tuesday night. But personalization walks a fine line. Overdo it, and it can tip into the uncanny. No one wants to open an app and see something like, hey, we noticed you cried last Thursday. Want a sad playlist? That's just creepy. Now let's talk about ethics and the age-old ethical statement, just because you can. Designing for engagement is one thing. Exploiting addiction is another. Responsible app design means building tools that empower users, not manipulate them. Some apps are already taking the lead. YouTube's Take a Break feature encourages mindfulness. Instagram and TikTok now warn users when they've been scrolling for too long. It's a small step, but a meaningful one. Transparency, user control, and wellness reminders don't just prevent backlash, they build trust. And trust is the ultimate retention engine. So, at its best, an addictive app isn't one that traps users, it's one that serves them. That becomes a habit because it makes their life better, easier, and more joyful. So build the habits, craft the loops, use the triggers and rewards, but do it with care, with purpose, with empathy. The most successful apps don't just capture attention, they earn it again and again. And if you can make your users feel a little smarter, healthier, calmer, or more connected than they were before, then congratulations. You haven't just built an app, you've built a ritual. And that's a wrap. I'm looking at the clock and it looks like I went way over my allocated time. So unfortunately, I will not be able to do the Q&A session as I originally anticipated. So thanks so much for joining me today. Whether you came here as a curious developer, a product visionary, or someone who just wanted to level up their app game, I hope you're leaving with new ideas fresh perspectives, and at least one aha moment. I covered quite the range: mobile app security, scaling both the front end and back end like a pro, protecting your stack from common pitfalls, and yes, how to make your app so engaging people forget TikTok exists. Okay, well, maybe not that addictive, but close. At the end of the day, scaling a mobile app isn't just about code or infrastructure. It's about creating something people want, trust, and love to use. And that's where the magic is. To borrow a quote from Steve Jobs, great things in business are never done by one person. They're done by a team of people. So, as you scale, build your app and your dream with others. Collaborate, learn from your users, listen to your team, and never forget that behind every successful product is a group of passionate people pushing it forward. Don't forget to iterate boldly, scale smart, break a few things, just not your production servers, and don't be afraid to build fast and learn faster. If you have any follow-up questions, ideas, or just want to geek out over architecture or app growth strategies, feel free to connect with me on LinkedIn or drop me an email. I always enjoy hearing what others are building and how you're tackling the big challenges. Thank you again for being here. I wish all of you success in your app journey. May your bugs be few, your users be loyal, and your servers never crash at 3 in the morning. Now go build something awesome.